This recording is for the assignment called Compound Events. There's a couple of vocabulary words you'll want to remind yourself of as you go through the lesson. Independent events, dependent events, probability. Those are all part of this assignment. So remember, dependent events are where the outcome of one event impacts the probability of another event. So if I had a deck of cards and I draw one card, there's a probability of what I might draw. And then if I draw another card after that, that would be a dependent event because it would depend on what I saw in the first card. Okay, so let's go through an example. So let's suppose I have some cards, and these two are red and these two are black. So we'll make the red ones a little more distinct and the rest ones are black. And let's say we have a spinner. Now this should be equal, even though my drawing might not show equal very well. And in my spinner there are some numbers. So 1, 2, 3, 4, 2. Okay, so here's what we want to do for a dependent event. So what is the probability you draw a red card and then spin a 1? So we want to draw a red card and then spin a 1. So we need to look at the probability of drawing a red card. So how many red cards are there? There are 2 red cards out of how many total cards? So there's 5. So the probability of drawing a red card is 2/5. Now let's go back and look at the spinner. How many possible ones are there that it could land on? So there are 4 chances that I would land on a 1 out of how many? And so if I count how many wedges, there's 8. So the probability of spinning a 1 is 4/8. And so what we do to find a dependent event with probability is we'll actually multiply these two together. So I know 4/8 reduces, so I'm going to change that to the 1/2, make it easier. And then for fractions we multiply across. So 2 times 1 is 2, 5 times 2 is 10, and that reduces to 1/5. So what we found is that the probability of drawing a red card and spinning a 1 is 1 out of 5, 1/5. Okay, another example, again with cards. So let's suppose we have these cards and these 2 are red. These are black. But now we have some numbers in them. Okay, so we want the probability of drawing a red not replacing it, so we're not going to put it back, and then drawing another red. Okay, so I draw a red card. So there's 2 chances out of 5 to draw a red card the first time. But now we've eliminated one of them. So if I eliminate one of them, now there's only 1 red card out of 4 total cards because I didn't replace that card back. And so the probability of drawing the second red card is 1/4. Now, to do that twice, then we multiply across, so we get 2 over 20, which is 1 out of 10. So there's 1/10 probability that I would draw a red card, not replace it, and draw another red card. Alright, next example. A quiz has 4 true-false questions. What is the probability of getting 100% on the quiz by randomly guessing the answers? So we have to think. The first question has 2 choices for answers, right? True or false. The second one also has 2 choices. The third also has 2 choices, and the fourth also has 2 choices. So we have to look at the probability of each one. So the first question has 2 choices, and I want to get the right answer. So that is 1/2, or 50-50 chance, right? When we say, oh, I have a true-false, I have a 50-50 chance of getting it right. 1/2. Same with all of them. They're all the same. 1 out of 2 chances I get it correct. Now I have to multiply those all together so that I would get 100% on the quiz. Then that means I have 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. So to randomly guess on a 4-question true-false quiz, my probability that I would get 100 is 1/16. The last example, a sample of 80 kids, 45% are female, were surveyed to see if they were employed outside of school. And then we find out 25% of the boys are not employed. How many boys are employed? Okay, so we have to look. They sampled 80 kids, 45% are female. So if we take the rest of them, that means that that's 55% of them are boys. 55% boys surveyed. So out of the 80 kids, 55% were surveyed are boys. And so how many is that out of the 80 kids? So 55% of 80, so 0.55 times 80, leaves us with 44 boys were surveyed. Okay, so that's not the answer to our question. What it asked us was how many boys are employed, but they said 25% of the boys are not employed. So 25% of the 44 are not employed, and so we have to figure out what that is. So 0.25 times 44 is 11 boys are not employed. So out of the 44 boys, how many are employed? And that would be 33 boys. So that's the end of this recording. Now you need to call, text, or Skype message me so we can go over this recording and you can get credit. Have a great day.